Walk onto the floor of a modern manufacturing plant and you will see nine-figure investment in automation and synchronized robotics. Yet, the tool measuring the efficiency of all that machinery is often a cheap piece of plastic. For over a century, industrial engineers have been used these stopwatches to monitor assembly lines and dictate the pace of production. But the manual nature of the stopwatch introduces a persistent discrepancy between the recorded times and the actual floor performance. Building a multi-million-dollar production schedule on these subjective data points leads to the efficiency leak that remains invisible to the management. The issue stems from the Hawthorne Effect, a psychological shift that occurs the moment a human being realizes that they are being watched. If an engineer stands by with the clipboard, a worker might speed up, pushing themselves to look more efficient to the observer. Or they might do opposite, intentionally slowing down their pace to ensure the company sets a lower daily quota. This chart shows the results spreadsheet filled with a uniform 45-second cycle times. In reality, these numbers are manipulated and do not reflect the actual flow of work. Since you cannot patch human psychology, capturing a true baseline requires removing the physical observer from the floor entirely. Moving to camera observation solves the psychological problem, but the standard MP4 video lacks the hard math needed for the management decisions. To find that math, AI uses HSV color filtering. The algorithm strips away the background noise of a factory to isolate the specific color values of a worker's glove or a specific tool. Once those colors are isolated, the system draws mathematical boundaries called as contours around them, plotting their locations against x and y axes. These processes converts the worker's presence into a trackable geometrical shape moving across a coordinate plane. By mathematically defining physical movement, the system removes observation bias from the data extraction process. These tracked shapes provides the foundation for automated time studies. Engineers map invisible digital zones directly over the physical workstation. The exact millisecond the contour of a hand enters zone a digital timer starts. When that contour reaches to zone B to grab a screw, the timer automatically stops, recording the precise transit time. These measurable micro movements are known in industrial engineering as Therbligs. The system tracks these movements 24 hours a day, measuring down to the milliseconds without ever inducing stress in the workforce. Why do enterprise companies spend so much time to measure a fraction of seconds? A human with a stopwatch only records the total cycle time. The AI records the variance of the task over an entire shift. This chart shows the difference. Amidst a steady 60-second cycle time, the AI identifies a tiny red spike. At 2 o'clock every day, a worker takes 4 extra seconds to grab a specific part. While a human eye misses this delay, the AI reveals machine vibrations, slowly shifting parts bin out of reach of a person as the shift progresses. This technology, or bolting that bin down and removing that 4 seconds delay when multiplied across thousands of parts, reclaims tens of thousands of dollars in annual profit. This technology identifies and removes the structural friction rather than forcing a human being to work faster. The era of the stopwatch is ending as the physical movement is translated into an actionable math. But once you have this continuous stream of real time data, where does it go? It flows into a digital twin, a living, breathing virtual copy of an entire facility. In the next video, we will break down the architecture behind these digital brains. Click here and see how they work.